Alright, in this video we want to discuss logarithms. In this video we want to discuss logarithms. Now the first thing to take note of is there is a relationship between indices and logarithms, and that's the first thing we're going to consider here. What is that relationship that exists between indices and logarithms? Now recall when we learned indices that 2 to the power of 5 gives a result 32. This 2 is labeled as the base. This 5 is labeled as the power. 32 is labeled as the result. Now this is in an index form. To write this in a logarithmic form, what you do is to write your log. Now in some books you see them write log as LG. So whether it is written as LG or it is written as LOG, you're saying the same thing. The base from the index form is 2, so the base for the logarithmic form will also be 2. The result is 32, so that gives you log 32 base 2 equals to your 5. I hope that is clear. Now, for you to know that you're right, is just to do something like this. 2 raised to power 5 equals to 32. So if we have a logarithmic form to be in this format now, log 81 base 3 is equal to 4, and you're asked to write it in an index form, I just tell my students to do this, and that gives you 3 raised to power 4 equals to 81. This is the relationship that exists between indices and logarithms. Now, the next thing we want to consider is how to evaluate logarithms. Evaluating logarithms. Now, if you're told to evaluate this log 625 base 5, log 0.25 base 4, log 4 base 0.5, log a raised to power 5 base a. Now I want to evaluate this. What we will do is to say for the first question, we'll let log 625 base 5, let's let this to be x. So we take this to be in logarithmic form. Let us express this logarithmic form as an index form. So we do something like this, and that gives us 5 to the power of x equals to 625. This is a simple index notation, and that means we'll have 5 raised to power x is equal to 5 raised to power 4. 5 will cancel out 5, and your x is 4. Quickly, let me say this here, that the base of the logarithmic form is always greater than 0. So take note of that. Now let's try the second question. The second question says, if we let log 0.25 base 4 to be x. The same approach. That will give us 4 to the power of x equals 0.25. Because this is in decimal, you express it as a fraction. And you will agree with me that if you express 0.25 as a fraction, you get 25 over 100, which is reduced to 1 over 4. So I'll just say 4 raised to power x is equals to 1 over 4. Going back to your indices, 1 over 4 is the same thing as 4 to the power of negative 1. So 4 will cancel out 4, and x is what? Minus 1. So you can conclude to say log 0.25 base 4 equals minus 1. Here also, you can conclude to say log 7 base 5 is equals to 4. Now, pause the video, try the third and the fourth. After you're done, you can then continue to see what the solution will be. Number 3, if we let log 4 base 0.5 to be x, that means that if we use the same approach, that means we'll have 0.5 raised to power x is equal to 4. Now, recall that 0.5 is the same thing as half. So half to the power of x is equals to 4. Now, you have to make the bases on both the left and the right to be the same. So 1 over 2 is the same thing as 2 raised to power 1 equals to 2 raised to power 2. So this is 2 raised to power minus x is equals to 2 squared. 2 will cancel out 2, and that means x is negative 2. So if x is negative 2, then I can conclude to say log 4 base 0.5 is equals to minus 2. And the last question that says log a raised to power 5 base a. So let this also be x. So that gives us a raised to power x is equals to a raised to power 5. A cancels out a, and x is 5. So I can conclude to say log a raised to power 5 base a is equals to 5. So this is the way you evaluate logarithms. Now, there is another form of evaluating logarithms. Now, this next evaluation we want to talk about is when you cannot express the index such that the base on both the left hand side and the right hand side will be the same. And this is where proper logarithm would come into play. Now we're going to look at some very wonderful questions, and you will now see how you can do questions like this. Now, if a question says find using calculator the value of the following. Number 1, let's say log 15. Number 2, log 7. These ones are very easy to do. You just plug your answer on the calculator and say log 15, and you will get an approximated value of 1.18. And in the case of log 7, you will get an approximated value of 0.85. But here is the kind of question I want us to examine. Now note also, when you write ordinary log, it means log to the base of 10. So log or LG means log to base 10. So if you have a question like this, log 5 base 2, Or rather, let us twist this question. And here's the twist. Find x if 2 raised to power x is 5. Yeah, this is the twist. Now, normally, you're supposed to make the base to be the same. But between you and I, you will agree with me that 2 raised, there's no value that will give you 5 when you raise to the power of 2. So 2 raised to the power what gives 5? It's not going to be a whole number. It's not going to be an integer. So what you do is this. When you have 2 raised to power x equals to 5, you add log to both sides. Add log to both sides. And that gives us log 2 raised to power x is equals to log 5. Now this power becomes a multiplier. You will learn that when you start the proper laws of logarithms. And that gives us x log 2 is equals to log 5. To get x, what do? We divide both sides by log 2 divided by log 2. So log 2 will cancel out log 2, and x gives us what? X gives us log 5 divided by log 2. Second. And that gives us 2.32 to 3 SF. So if you do 2 raised to power 2.32, you will get a value very close to 5. And that's how it operates. Alright, I hope this video helps you to understand the basic technique in logarithms. In our next video, we're going to examine the laws of logarithms. Thank you.